What is the meaning of that spotlight? Yeah. Okay. Mr. Francis, can you step down?
Do I know this one or not?
Yeah, you just be walking.
What is it?
Yeah.
Okay, good morning all. Today we are looking at operations with polynomials. And operations with polynomials, we need to know how we add, subtract, multiply, and divide polynomials. But before we do that, let us see what is a polynomial. So I want to believe you all are seeing the slide. So this is an example of a polynomial, so you understand what we are trying to say about polynomial. A polynomial of 2 terms is a binomial, as you have seen on your slide. You can turn to your slide. So a polynomial of 2 terms is a binomial. An example you are seeing on the board is when you have 7xy plus 2x squared. This is an example of a binomial because you have 2 terms. This is the first term and the second term. But when you have 3 terms, an example is 8y squared, as you are seeing on your board. That's 8x squared plus 12xy plus 2y squared. This is of 3 times, so it is called trinomial. Trinomial. First term, second term, third term. We now move to what then is the degree? What then is the degree of this polynomial? That will take us to the next slide. But before we talk about degree, let's look at the constant time. You see this constant time here? That's before the x variable is called the constant time of that variable. So for instance, the constant time of this one is 8. That's the coefficient, is the leading coefficient. Now, again, we may want to look at what is the degree of a polynomial. This is how we know degree of polynomial. The degree of polynomial, as you have seen, is the degree, the highest degree in that polynomial. For instance, when you have something like this, 6x cubed plus 4x squared plus 6x minus 5. This is polynomial of 4 times. The degree here, the highest degree is 3 because you have degree 1, degree 2, degree 3. So this one here is what we call the degree. That is the degree. And of course, the 6 here is what we call the leading coefficient. The leading coefficient, as you have seen. But now, anyone that does not have x or y, that does not have any of the variable, is called the constant term. So as you can see, like this minus 5 is the constant term. So that's what we call polynomial in degrees. Now, the degree of a polynomial is the greatest of the degrees of any of its terms. we may want to consider a situation. This is polynomial is of degree 3. Let us look at some degrees of polynomial here. Now, okay, let's extend degrees of polynomial. As you can see in the board, if you have something example, when you have a 3y squared plus 5x plus 7, what is the degree of this polynomial? The highest degree here is 2. So this is of degree 2. But what happened when you put x and y together, as you have seen this second example, like 12x is to power 5y plus 3y cubed plus 2y squared. This is x raised to power 5 and y. Y is same thing as y raised to power 1. So the degree here in this example is actually 5 plus 1 that is here. So this is of degree 6. Now, but if you have something like, look like y equals to ms plus b, e.g., if you say y equals to 4x plus 2, this is an equation of a straight line. So in this case, this is of degree 1, just 4x, as you can see. So this is of degree 1. Now, let's go on to see how then do we multiply, how do we add, how do we subtract, and then of course, how do we divide polynomials of different degree. But before we go on, your normal quadratic equation that you know, the normal degree, the quadratic equation that you know is of degree 2. An example is, if you have given quadratic equation, an example, the one with as squared plus bs plus c, where f of x is equals to this. This one is of degree 2, and that is of degree 2 is the same thing as quadratic. That's from where we got quadratic equation. This is of degree 2, degree 2. So let's see how we add okay. Let me know if there is any question. Okay. The whole work will be clear right now. Okay. 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 Let us start over to know how we know degree of a polynomial. I want you at this moment to go through your slide. A polynomial of 2 terms is binomial. We are just talking of the terms now. Now, an example of binomial, when you have something like 2x squared plus y squared, this is two terms. We have trinomial. An example is 8x squared plus 4xy plus 6y squared. If you look at this, this is 3 terms. Now, we want to know, Chidera, you are looking at the topic operations with polynomial. That is the topic. Okay. 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 Now, as you can see, so this is an example of trinomial. It is trinomial because it has 3 terms. 1, 2, 3. That's 3 terms. So it is trinomial. Now we want to consider how do we get the degree of a polynomial? To get the degree of a polynomial, in order to get the degree of polynomial, please, I want you to go through your slide now and see what you see on the board. When you have, e.g., 6x cubed minus 2x squared plus 8x plus 15. We want to consider degree of this polynomial. You need to look that what is the degree that is the highest here. This one is degree 1. The power here is 1 that you cannot see. The power here is 2, and the power here is 3. So this polynomial is of degree 3 because it has this. This is the highest. So this is polynomial of degree 3. We are talking of degree. Now, the one with the highest degree will be the one to have what we call the leading coefficient. So the leading coefficient here is 6. That is the leading coefficient. So this is polynomial of degree 3. And of course, why is it degree 3? Because it is the highest here. Now, what is the leading coefficient? The leading coefficient is 6, because this 6 is the one that have the variable that have the highest degree. Leading coefficient cannot be -2, because 2 has x that is raised to power of 2, but there's power of 3 here. So this is the leading coefficient. Do you all get this now? Okay. Now, this is not about quadratic equation, and this is the next topic after equation of circle. We are just trying to explain the general how polynomials look like. How do we add polynomials together? How do we subtract? How do we add? That is just what we are doing. So now, in this polynomial of degree 3, because this is x raised to power 3, and of course, this is the leading coefficient. So I want to ask you a question now. I want you to tell me, what is the degree of this polynomial here? What is the degree of this polynomial and the leading coefficients? We have 5 minus 6x plus 7x squared minus 8x cubed. What is the degree of the polynomial above, and what is the leading coefficient? I want you, who can tell me that? You can type your answer. Let me see. Thank you, thank you. Thumbs up, thumbs up, thumbs up. You did well. Look at this. The degree is 3. Leading coefficient, is it 8 or -8? Look at it. Good, good, good. Yeah, Ismail Mustafa, well done. -8, thank you. Edun, very good, -8. Yes, thank you, Miriam. You are all correct. Thank you. Kauta, well done. This is correct. The leading coefficient is -8. Thank you. Now, what happens when we have x and y together? How do we get the degree of the polynomial? And so this one is different. Thank you, Rakib. You got it too. Let's see what happens when we have x and y together. How do we get the polynomial? Let's change this question here. Look at this. Let us see how we can get polynomial when they are together. When you have x and y together. You have 21x raised to power 5y plus 3y cubed plus 2y squared. Here, the degree here, very good, Kuwam. The leading degree here, who can tell me the leading degree here? In this one. The leading degree here is 6. Very good, Edun. This one is 5. These ones are together. You will not add it. You know, this one is y. There is 1 there that is not showing 1. So the leading degree, is 5 plus 1, which is equals to 6. So this is 6. The leading degree is 6. Thank you. Very good, Kuwam. Very good. Very good. But for this one, the leading degree is 5. Now, the leading coefficient is 21. Leading coefficient is 21. But this is of degree 5, while this is of degree 6. Very good. Edun, yes. Very good, very good. Thank you. Miriam, welcome, thank you. Okay, now let us see, how do we add? Okay, Kauta, ask your question. I have a question. Hello, Kauta, what's your question?
Sir, what if X and Y both have the leading degree, but they have different coefficients?
They have different coefficients. Is
Yes,
it like this one?
No, like X, let's say there's X square and Y square. And then X coefficient is 3 and Y coefficient is 2.
Okay, you pick the one that is highest. Can you give an example of the equation?
3x square
3x square
plus 8xy
8xy
plus 2y square.
plus 2y square. In this case, we say they all have what? Equal power. Do we get that? They all have equal degree. So the degree here is 2. In this type of situation, you do not have the one that we say you call the leading coefficient. Everything is 2. Do you get?
Yes, sir.
Okay, but if you add y to this one becomes of degree 3. But if I remove it the way you have said, that means everything is 2. And so we cannot talk about leading coefficients here. Do you get that now?
Yes, sir.
Okay, very good. So let's continue. Let's see how we are going to be adding, subtracting, multiplying, and of course, dividing polynomials of different degree. Chidera, how are you? Okay. So let's continue. Let's see how we add. To add polynomial. So we are going to do things here now. We will start from addition. Let's see how we are going to be adding. Addition. To add, all we need to do is to do what? Just rearrange, and you must collect the ones that have the same power. Example 1 on your board. Example 1 on the board. Add 5x cubed plus 6x squared plus 3 plus another polynomial 3x cubed minus 12x squared minus 10. So we want to add this and this together. All we need to do is to rearrange in such a way that we collect terms. There is plus before this one, so open the bracket. So if we open this, we have 5x cubed plus 6x squared plus 3. Plus to multiply all this because you are going to open the bracket. That will be plus 3x cubed minus 12x squared minus 10. So collect like terms. This is x cubed. Is there anyone with x cubed here again? No. So we are going to have only 5x cubed. This one have x squared, another x squared, another x squared. Bring all of them together, the one with square. So you have plus 6x squared plus 3x squared minus 12s squared. There is no one with s squared, then minus 10. S cube has power of s raised to power 3. So there is no one that have s cube again. So that's going to be the only one. So you have 5s cube. Now look at these three. You all have s squared. Meaning that you can put them together. That is 6 plus 3 minus 12. 6 plus 3 is 9. 9 minus 12, that is minus 3. So you have minus 3 s squared. Then this minus 10 is just the only one standing. Minus 10. And so this is your answer. Your answer is on degree 3, and the leading coefficient of your answer is 5. Is there any question? This one, do we all understand this? Okay, let me explain again. We want to add this polynomial plus this one. All you need to do, if there is brackets, make sure you open the brackets and collect like terms. Okay, Daniel, I'm explaining again. You need to open the brackets and then do what? Collect like terms. The question is on your, you can see this question displayed on your screen. 5s cubed plus 6s squared plus 3. You want to add it to another one like this. So what you need to do is to open the bracket. Once you open the bracket, then you will collect like terms. The one that have s cubed for s cubed, the one that have s squared with s squared, the one with constant will be with constant. So 5s cubed plus 6s plus 3, that is everything you have seen here. Then there is plus before this sign. You will use this plus as before the bracket to open the bracket. So we have plus 3s squared plus times minus 12 minus 12s squared plus times minus 10 minus 10. Then you do what? You collect the terms. Look at this, 5s cubed. There is no one with s cubed again, so it's standing alone. Now we have s squared, s squared, s squared. So all the s squared, you bring them together. This is just saying 6s squared plus 3s squared minus 12s squared. 6 plus 3, 9. 9 minus 12 is minus 3. So this is minus 3s squared. And that is what you see here, minus 3s squared for this 3. Then minus 10, and this is this. Please, do we all get this now? Fatima, any question? Okay. Okay, yes, I've seen it. This is 3s cubed. Thank you. Thank you. Fatima, thank you. You're saying 3s cubed. We collect like times. It's obvious. Thank you. 5s cubed plus this one is 3s cubed, not 3s squared. Plus 3s cubed plus 6s squared minus 12s squared minus 10. Thank you for pointing that out. Thank you. Thank you, Dawodu. See? So this is 3s cubed, not 3s squared. Now we have 2s cubed. That is 5s cubed plus 3s cubed. That is 8s cubed plus 6s squared minus 12s squared. That is minus 6s squared, then minus 10. Thank you. Same. Good, good, good. Couch up. Okay. Very good. Very good. We can go on now. The same. So let's see. Let's make it a little bit much more complicated. So let's look at example number 2. We want to add 3 different polynomials together.
Minus 3 plus 10. Minus 3 plus 10. Minus 3 plus 10 minus 3.
Okay, plus 3. Yes, okay.
Yes.
Plus 3 minus 10.
No, we don't need to think. Okay.
That is minus 7. Minus 7. Thank you. Okay. Thank you. Yes. Abdul, thank you. It's good. You people are following very well. Very good. Thank you, Miriam. Sin. Very good. Thank you. Thank you, Abdul. Now let's look at a much more complicated problem here. We want to add 3 different polynomials together. So let's add these together. Add 6x cubed plus 11x minus 21. We have plus another one, 2x cubed plus 10 minus 3x, close brackets, and of course the last one, 5x cubed plus x minus 7x squared plus 5. Now let's do this one. After this one, we can try our own. Abdul, stop abusing someone there. Okay. Now, can you people concentrate and stop abusing yourself? Let's do this together. Let's arrange them. It's your choice if you want to arrange them or you just want to collect terms. So let's just make everything in one line and then we collect terms. We have opened the brackets. You have 6x cubed plus 11x minus 21 plus 2x cubed plus 10 minus 3x plus 5x cubed plus x minus 7x squared plus 5. So we need to identify the ones with cube. Plus 6x cubed plus 2x cubed plus 5x cubed. So the ones with cube, that is 6x cubed plus 2x cubed plus 5x cubed. No other one with cube again. And so we move to the one with square. It's only minus 7. Minus 7x squared. Now we move to the one with x. Plus 11x minus 3x plus x. That is all. And then we'll move to the constants. We have minus 21. Then plus 5. That's all. I hope I'm not skipping anything this time around. Minus 21 plus 5 and then plus this 10. So 6x cubed plus 2x cubed. That is 8x cubed. Clear? Plus 5 there. That is 5 plus 8. Let me do everything at once. That is 13x cubed. Minus 7x squared is the only one there. 11 minus 3 plus 1x. So we're going to have 11 minus 3, that is 8x, plus 1, that is 9x. We have plus 9x. Minus 21 plus 5 plus 10. That's minus 21 plus 15. And that's minus 6. Thank you. Okay, Fatima, you said you can't see the board. Are you seeing it now? Fatima, not seeing, it's not seeing the board. Let me speak with Fatima, please. Oh. Okay. Let me see. Hello, Fatima. Can you see now?
Don't worry, sir. I'll use YouTube.
You use what?
YouTube.
Okay, sorry. Sorry. Okay. But just try, maybe you can position your, I don't know, maybe the screen. Okay. I want you to know there is what we call an additive inverse of a polynomial. Additive inverse of a polynomial is just extracting the minus out. Because there are times that you might need to extract minus out. It makes your work easy. For instance, if you are given, let's say you have a x squared plus 4. Let's say plus 4x minus 2. The additive inverse is that you want to extract minus out from this work. So additive inverse is just you multiplying it by minus. So you can go front, you can go back. Additive inverse is just that multiply this one by minus. It will be minus, and then you have x squared plus 4x minus 2. That's what we mean by additive inverse. Yes, you can extract minus out. So let's see what we can do, because additive inverse sometimes is pure waste of time. You can open brackets. And so let's move to more example on subtraction of polynomials. Okay. Let's see how we can subtract two polynomials. It's just the same thing, multiply by minus, and then do your work. Now, I want us to try this. Find, we've been given p of x and the value here. So we are going to do a lot of things with this one. The p of x, that's a polynomial, is given as 2x squared minus 3x plus 1. And we have an r of x to be given as x cubed plus x plus 5. Find A, P of x plus R of x. B, P of x minus R of x. And C, let us evaluate P of x minus 3 R of x. Everything we just follow same procedure. But when you see a constant before a polynomial, it means you are multiplying that polynomial by the constant. So let's quickly look at this, and then the class will end here today. So next class, we'll continue with multiplication of polynomials and, of course, division of polynomials. Let's quickly look at the solution to this work. Do you think you can do this thing? Should I give you the work while I see your solution? I want you all to try this. Okay, previous slide. Is it this slide you're talking about, Chidera? I am changing the question. This is what I want to use to explain. S cubed, so let's work with this. Okay, you prefer I use the minus? It's all right. Let's put the minus there then. Okay, so that it can rhyme with what you have there. I want you, okay. We are on the slide already. Now, I want you all to try this in the next 5 minutes. Just try, attempt that. Okay. I want to give you this work to try by yourself. You have to do, please look at the question very well or copy it from the slide. But what I want you to do, I will do A for you, then you can continue with this one. The solution to the first one to the first question. The P of x A plus R of x. P of x is 2x squared minus 3x plus 1 plus the R of x, which is minus x cubed plus x is this. We have minus x cubed plus x plus 5. Now you are going to use plus to open this bracket. And so this should be 2x squared minus 3x plus 1 plus times minus minus x cubed plus times plus plus x plus times plus, that will be plus 5. Now collect times, so you have minus x cubed. X squared is the only one standing. This is plus 2x squared minus 3x plus x. That is minus 2x. 1 plus 5. That is plus 6. And that will be your answer. Well done. Well done. Abdul, you have done it. Okay, Iman, very good. Minus should be in your, this one, plus 2x squared minus 2x. Very good, Kuam. Very good. Very good. Minus should be there. Very good. Now, I want you all to try this as your homework. But when you want to do this one, you are going to change this to minus. And when you change this to minus, remember, you will use minus to multiply all this and change your work. And this one, of course, I'm looking forward to those that will get it, but I'm sure most of you will get it. So take this as your homework and let me have the solution. Okay. Oh, plus 2x squared. It's not plus 2x squared. Okay. Enjoy your weekend. Try this too. Make sure you try this one. Get the answer and submit. So this is the final answer here. Okay, counter also. Hello, counter, we can talk. You are asking something?
Yes, sir. The last class.
Okay.
The last class video. It's not on YouTube, and I was not in class.
Okay. Oh. I will speak with the IT to upload it.
Okay.
Okay. Okay, they said they've done that now, so you can check.
Okay.
All right. Bye.